Hello, everybody. This is Exponent Laws I. This refers to section 2.4, and we are learning about what we can do when we are multiplying or dividing powers with the same base. So make sure you're filling in the blanks as you go along. So this is the number one, the exponent law for product of powers. Remember, product is when you multiply. So when multiplying powers with the same base, you add the exponents. Add. So here we go. A to the power of m times a to the power of n equals a to the power of m plus n. And I know not everybody are letters people, so let me show this for you in numbers as well. So if we had 2 to the power of 3 times 2 to the power of 2, this is basically the same as 2 times 2 times 2, that's the 2 to the power of 3, times 2 times 2, that's the 2 to the power of 2. And if we count them all up, we realize we have 2 to the power of 5, which is the same as just adding those exponents right there. So the exponent law for the quotient of powers, this is when we're dividing. Remember, quotient is the result of dividing. So when dividing powers with the same base, subtract the exponents. So if we have a to the power of m divided by a to the power of n, it's the same as a to the power of m minus n. And I'll show that for you again. So say we got our 2 times 2 times 2 divided by 2 times 2. So this is our 2 to the power of 3 divided by 2 to the power of 2. You can essentially cancel those out, and what we're left with is a 2 to the power of 1. So if we had 2 to the power of 3 minus 2, we would also get 2 to the power of 1. So I'll do some examples, and hopefully that will help to kind of solidify this idea. So let's look at the first example, 5 to the power of 4 times 5 to the power of 2. We could rewrite this as 5 to the power of 4 plus 2, and that would give us 5 to the power of 6. Here we have 3 to the power of 6 times 3 to the power of 5, so we can write that as 3 to the power of 6 plus 5, and we get 3 to the power of 11. Here we have 7 to the power of 4 times 7 to the power of 1. So we could write that as 7 to the power of 4 plus 1. And we get 7 to the power of 5. Now we're looking at the exponent law for quotients of powers. Okay, so now we're dividing. We can rewrite this as 5 to the power of 4 minus 2. And we would end up with 5 to the power of 2. Here, 3 to the power of 6 divided by 3 to the power of 5. So 3 to the power of 6 minus 5, we get 3 to the power of 1, or just 3. Here we have 7 to the power of 4 divided by 7 to the power of 1. So 7 to the power of 4 minus 1, or 7 to the power of 3. I'll do a couple more. So see here, we still have the same base. It's just minus. That's okay. It's in brackets. So we have minus 8 to the power of 4, and it's multiplying. So we're going to be adding those exponents, and we're left with negative 8 to the power of 12. We've got negative 9 to the power of 12 divided by negative 9 to the power of 1. So we do 12 minus 1, and we get negative 9 to the power of 11. And here we have negative 4 to the power of 7. It's multiplying, so we're going to add 12, and we get negative 4 to the power of 19. We can do it when there's multiple steps as well. So we have 2 to the power of 2 times 2 to the power of 6. We're going to add those. We get 2 to the power of 8 divided by 2 to the power of 4. 2 to the power of 8 divided by 2 to the power of 4 means we're going to minus our exponents, and we're left with 2 to the power of 4. Here we have negative 2 to the power of 5 divided by negative 2 to the power of 3. So we're going to do 5 minus 3 and get negative 2 to the power of 2. And that's still multiplied here by this negative 2. And that's secretly to the power of 1. We multiply those two, add the 2 and the 1, we get negative 2 to the power of 3. Okay. Here's some little information on using quotient laws and order of operations. This is just a couple examples on our second day notes. We'll do a little bit. I'll do a few more examples with you. And I did kind of delete this sentence here because I thought it kind of led you astray. So hopefully this sentence is a little more clear. So when equations involving numbers with bases have multiple steps, we use BEDMAS to simplify first, and then we evaluate. Okay, so let's look. Here we can, we have a multiplication question that we can simplify first before we convert our powers into standard form and solve it that way. So let's write this as, so we have a 0 plus a 1. So we can have 2 to the power of 0 plus 1 is 1. So we still have our 2 squared, subtract, and we still got our plus 2 to the power of 3. But we simplified this, okay, into 2 to the power of 1. And now let's convert to standard form and solve. So 2 to the power of 2 is 4, subtract 2 to the power of 1 is 2, plus 2 to the power of 3 is 8. And then we can get 4 minus 2 is 2, plus 8 is 10. And let's do this one. Let's look, we can simplify here. We have a same base and it's being divided. So we can minus the 6 and the 5. We end up with negative 2 to the power of 1. That's 6 minus 5. And then we can simplify this as well. So minus, it's being divided again. We have 5 minus 3, so negative 2 to the power of 2. Now we can put each of these into standard form. Negative 2 to the power of 1 is negative 2. Subtract negative 2 to the power of 2, so negative 2 times negative 2 is 4. And we get negative 2 subtract 4 is going to be negative 6. All right. Thank you so much. I'll tell you what textbook questions are for today.